Okay, so this is chapter 2 from Giancoli, and it's the beginning, what we already talked in class. No? So we said that in chapter 2 we'll be discussing mechanics, which is the study of motion, and we talked a little bit about some main figures in the development of mechanics. We talked a little bit about Galileo Galilei and also Isaac Newton, which are symbolic figures in the development of mechanics. Of course, science is not developed by just one or two people, but by many more. They're just symbolic figures. And then we talked about Galileo's contribution in terms of the accelerated motions, uniformly accelerated motions, and also his problems with the Inquisition. And we mentioned the great play by Brecht, which sometimes comes to New York, so should keep an eye on it, and where he has that moment of resistance where he says "Epur se mueve," meaning that but Earth does move. And then we talk about Isaac Newton, and this will show up a lot in chapter 4 and chapter 5, his contributions about universal gravitation and also calculus. And we talked a little bit about Deva Sobel's book, Longitude, right? And anyway, as I said, it's not just two people that developed the whole science. In particular, I called your attention to Émilie du Châtelet, who was a great woman, a great scientist, and she's the person who promoted Newton's physics in France, and she also made important contributions, in particular to kinetic energy. So when we go to chapter 6 and start talking about kinetic energy, we'll come back to her. Very well, so let's go and talk about the important definitions related to mechanics. So as we said, we will divide mechanics into two main parts, which is kinematics and dynamics. So we'll start talking about kinematics, which is just how the objects move, how fast, what is the acceleration, what is the velocity of the object. And then later, not in this chapter, but in future chapters, we'll talk about dynamics, which is the whys. Now, what causes this motion? What causes the object to change its direction, or to accelerate, or to stop, and so on. Very well. When we talk about kinematics, what we are going to do, which is the main point of modern science, is let's try to simplify this motion as much as we can before trying to describe it completely. So what do we mean by that? Let's think about what possible motions do we have. Translation. Translation is a basic motion. That's what we are seeing here in A. This object is falling, so it's translating, and also in B, it's also translating. But if I compare A and B, B is more complicated because in addition to translated, it's also rotating. So what we are going to do now in chapter 2 is we are going to forget about rotations and let's focus only on translation. Now, this translation can be in 1 dimension, 2 dimension, 3 dimension. Let me simplify it. Again, simplification is our goal now. And let's think about the motions that are in 1 dimension, so a straight line. Okay, and finally, while this is a complicated object, let me simplify it. Let me think about it as a single particle, as a single point. So I don't need to worry about the shape of this object and what each point of this object is doing. So, as I said, we are simplifying. Now we are idealizing everything. And this is the main features of modern science. Now, simplification before putting all the elements take all the elements into account. All right, if I'm going to describe the motion, first thing I need to do is to identify a reference frame. So it's with respect to a reference frame that I'll talk about position, that I'm going to talk about velocity and so on. Suppose someone calls me, someone is going to meet me and ask me, where are you? And if I say, I am at 400 meters. 400 meters. Of course, this information is incomplete. The person is going to immediately ask me 400 meters from what? So with this question, the person is asking me, what is your origin? What is your zero? Okay, so if I tell the person, wow, I'm at 400 meters of the main entrance of Grand Central. Okay, so now I set the origin, but that is still not enough. The person is going to ask me, is it to the right or is it to the left? Right? So what we need to describe a motion is a reference frame. We need an origin, we need a set of coordinates, and then everything will be given in terms of that set of coordinates, in terms of that reference frame. Same thing here. Here we have a man walking inside a train, right? And this train is also moving. So if I'm going to give his speed, I have to tell you, what is the speed? Is this the speed with respect to the train, or is it the speed with respect to the train station? So these are different things, the importance of the reference frame. Okay, so we'll be talking about one-dimensional motion, so I can pick just one of these coordinates, just the x if I'm talking about horizontal motion, just the y if I'm talking about vertical motion. Alright, so let's go to some definitions. Let's defining distance first. Distance is simply how much the object traveled. So it's what we call a scalar. That is, it is a number with units. Remember, we agreed that numbers in physics will always have to come with a unit, otherwise it doesn't make any sense. So the distance is how much the object traveled. So we give a number, a positive number with unit. Distance is length, so in the international system we would use meters. Okay, so let me show you a little example here. Suppose someone started here, the origin, moved 70 meters east, and then moved 30 meters west. So what is the distance? How much did this person travel? Well, this person traveled 70 plus 30. So this person traveled 100 meters. Then how many steps did this person give? So this person traveled 100 meters. Now comes a different definition, which is displacement. Displacement is how far the object moved from the starting point. So how far away from that origin did the person go? So displacement is an important quantity. It has more information than the distance. Displacement is a vector. And as a vector, we have to give two pieces of information. We have to give the magnitude of the displacement, and we also have to give the direction. We have to say how far this person moved away from the origin and in which direction. Was it to east? Was it to west? Was it north? Was it south? Okay, so in this particular example here, the magnitude of the displacement would be the final position, so x2, the final position, which is 40, minus the initial position, x1, which was 0. So the displacement, the magnitude of the displacement of this person was 40 meters. But this is not all. If I want to give displacement, I cannot talk just about the magnitude, I also have to give the direction. So the complete answer would be this person moved 40 meters east. Okay, now since we are talking about one-dimensional motions, there are just two possibilities: east and west, up or down, right or left. And instead of these words, what we are going to associate with these two directions are two signs, plus and minus. Okay, so in this particular frame here, I said that motion to the right is motion in the positive direction. So the answer for the displacement would be enough to say the displacement was plus 40. Okay, this plus means in this case to the right, in this case means to the east. All right. Together with that definition, those definitions for distance and displacement, we are now going to talk about speed and velocity. And we are going to be talking about average speed and average velocity. So what is average speed? The average speed is the distance the quantity that we just talked about, the scalar that we just talked about, the distance divided by the time that it took for the object to move that much, no, to get that whole distance. So average speed, just like distance, is a number, is a scalar, is a positive number. So the average speed, which is distance divided by the time elapsed, is going to be a number with unit. And what is the unit? Well, if the distance is in meter and the time is in seconds, so if we are using the international system units, then the average speed will be meters per second. Okay, what is average velocity? Well, similar idea, but now in terms of displacement. And if I'm talking about displacement, well, then average velocity is also a vector. Average velocity also has magnitude and direction. What is the definition of average velocity? And I'm using this bar here to mean average, okay? So the average velocity is the final position minus the initial position, which is displacement, divided by the time. And we see from this equation that the direction of the average velocity is the same one as the direction of the displacement. If the displacement was plus, the average velocity will be plus. If the displacement was minus, the average velocity will be minus. And plus and minus here does not mean more or less, it just means the direction, right or left, east or west, and so on. Units, meters per second, if we are using the international system. Okay, so let's think about that example that we talked before about that person that moved 70 meters east and then 30 meters west, and let's assume that it took 10 seconds for this motion. What is the average speed and what is the average velocity? Well, the average speed is the whole distance, which is 100 divided by 10, so that is 10 meters per second, just a number with a unit. And what is the magnitude of the average velocity? The magnitude of the average velocity is the displacement, which is just 40 divided by 10, so 4 meters per second. And if we would ask, what is the direction of this average velocity? Well, in that example was east, right? So the complete answer here would be the average velocity is 4 meters per second east. In the choice of sign plus and minus, we could say plus 4 meters per second. Very well. So let's do now some exercises. And the idea here, 3 simple problems. So in the first problem, well, let's read carefully, right? So we say that in 3 seconds, a runner position changes from 40 meters to 30.5 meters. And we want to know what is the this runner's average velocity. Okay, so here we are. Let's write down all the information that we have and try to get the answer. So what do we have? Delta t, which is the time elapsed, is 3 seconds. All right. The runner's position changes. It was initially 50 meters, and at the end it became 30.5 meters. Okay. If I want, I can write all this, can make a drawing for all this. So I can choose my reference frame, say that some point here is 0, say that this is plus 50, for example, and that this is plus 30.5. This is in meters. And then what we have here is this person moved from this position all the way to this position. So you can see that according to my reference frame, this person is moving in the negative direction, right? So the displacement of this person will be negative, a certain number. And this negative only means that this person is moving to the left in my drawing, all right? So What is this displacement? Well, this displacement will be the final position, 30.5, minus the initial position, which is 50. And you can get a number here. And what is then the average velocity? Well, the average velocity will be the displacement divided by the time. The displacement here is negative, right? It's minus 19.5 meters. And then if we put it here, minus 19.5 divided by 3.0, we will get that minus 6.50 meters per second. So this answer is complete because we are given the magnitude and we are given the direction. Okay, all right, so now let's move on and try to answer